All right, we're back. Up to question 16. About our bowling ball. 6 kilogram bowling ball is found to slow down from 30 kilometers an hour to 10 kilometers an hour in a time interval of 13 seconds. Seconds is right, so we're happy with that. Okay, this is in kilometers an hour. We know we can't use that, so let's convert that. 30 divided by 3.6, 8.33. This is meters per second now. To 10 divided by 3.6, 2.78. Okay. So, what's the ball's deceleration during the 13-second interval? So, acceleration is change in velocity over change in time. The change in velocity is final minus initial. Right, so final is 2.78 minus initial is 8.33. Delta T is 13. So 2.78 minus 8.33 divided by 13. Acceleration is 0.43 meters per second squared. Should it be negative? Well, yes, it's gotten slower. It's gone from 30 kilometers an hour to 10 kilometers an hour. Or, alternatively, it's gone from 8.3 meters per second to 2.8 meters per second. So, it seems sensible to me. Alright, moving on. What was the average braking force acting on the ball during the time interval? Okay, so we found out that its acceleration is minus 0.43 meters per second. And what else do we know about the ball? We know its mass is 6 kilograms. Force. Alright, we can see what's happening here, can't we? F equals ma. 6 times by minus 0.43. So the force required is going to be 2.56 newtons. Okay, and we can see that it's a negative here. So all that negative is saying it's in the direction opposite to the direction of motion. And that makes sense. So if you've got a force opposing the motion, it's going to make the object slow down. The average braking force acting on the ball during the time interval, 2.56 newtons. Explain what happens to the kinetic energy that was lost over the 13 seconds. Alright, so this bowling ball has lost kinetic energy. And kinetic energy is a half mv squared, that's on your formula sheet. And, well, the mass of the bowling ball doesn't change, and a half is always a half, but this has decreased, the velocity has decreased, so therefore this is decreased. Okay, so we know that. The question is, what happens to that energy? And we know the law of thermodynamics states that energy can't be created or destroyed, so it's been converted into another form. And the force that slowed the ball down is friction. And so when friction's acting, you've always got heat. So heat, and there's also going to be some sound. All right, in a perfectly silent room with a very sensitive microphone, you would be able to hear the bowling ball roll along the carpet. 2 marks means the examiner's fishing for 2 answers. And really, this is your default answer all the time. What happens to the energy that's been lost? Heat, always. And probably 80% of the time it's going to be sound as well. Alright. Question 19 refers to the following information. Boy dragging a box. The box is moving at a constant velocity. Constant velocity, we know this means the sum of forces is equal to 0 newtons. That's what that means, at 6 metres per second east. Alright, so this must be east. The buoy applies a constant force of 90 newtons along the rope. The rope makes an angle of 30 degrees to the horizontal. Okay, that's in the picture. Okay, what are they going to want us to do? Calculate the magnitude of the resistance forces acting on the box. Justify your answer. Okay, well, it's moving at a constant velocity. So therefore, whatever horizontal force has been applied here is equal to the horizontal force opposing it. So what we need to do is we need to find the horizontal component of this force. So this becomes a trigonometry issue. There's our block on the ground. There's our 90 newtons. And I probably should have done this as a dotted line. And there's our triangle that it makes. And that's 30 degrees in there. Alright, so what we want to find out is the horizontal component to this force. This force is applied at an angle, so some of that force acts vertically and some of it acts horizontally. And we can say that most of it actually acts horizontally and some of it acts vertically. Okay, so let's attack this triangle first. Alright, trigonometry, SOHCAHTOA. This is the hypotenuse, the longest angle, and the edge of the triangle we want to find is the one adjacent, the one next to the angle. So hypotenuse and adjacent. Hypotenuse, adjacent. So it's cos theta equals adjacent over hypotenuse. Alright, we fill in our numbers. Adjacent is our unknown. Hypotenuse is 90. Multiply both sides by 90 to get rid of this. So we've got 90 cos 30 equals adjacent. Alright. 30 cos times by 90 equals, so adjacent equals 77.9 newtons. Okay, so this is in newtons. Alright, that seems right. We know if we had a number more than 90, then it's definitely wrong. So, I'm happy with that. So, that means the horizontal component of the force is 77.9 newtons. And that means, because it's moving at a constant velocity, the force acting that way is equal to the force acting this way. So, that means that the force of friction has to be equal to 77.9 newtons. And it actually gave a direction, saying he was dragging it something about east. Did I see that? So it's moving at 0.6 metres per second east. So that means the frictional force is actually going to act in the opposite direction, so that has to be west. Okay, so to justify your answer, you'd want to say that because it's a constant velocity, some of the forces are zero, therefore the frictional forces have to equal the horizontal component of the applied force. Okay, you might want to replay that a couple of times. It does make sense when you get it. It might sound a bit bizarre. Alright, section C, light as a wave. Which of the following statements is incorrect? Mechanical waves are made up of a series of pulses. Well, they can be. Mechanical waves must have a vibrating item at their source. Absolutely. My vocal cords are vibrating, which is producing a sound, and sound is a mechanical wave. All waves transmit energy but don't transmit materials. That's right too. So by default this should be wrong. Let's have a look. All waves travel in the same direction as the vibration of the particles in the medium. Okay, that is the incorrect answer. Because we've got two types of waves. Transverse and longitudinal. And this statement is describing a longitudinal wave. It's a correct statement for longitudinal, but not a correct statement for all waves. Question 21, a submarine sonar equipment sends out a signal with a frequency of 31 kilohertz. Kilo is 1,000. If the wave travels at 1,400 meters per second, what's the wavelength? Alright, our wave equation is here. V equals F lambda. V equals F lambda. V is 1400. Substitute in our numbers now. Alright, to get lambda by itself, we divide both sides by 31,000. Therefore, wavelength is 1400 divided by 31,000. Wavelength is 0.045, and it's meters. Wavelength is always measured in meters. So, 0.045 meters, which is actually, if you want to convert that, that's 4.5 centimeters. Alright, I'm not sure how long this one's gone for, but I'll stop this one now and we'll continue from 22 on the next one. Hello there.